All right, so we're going to take a look at this graph and use it to answer this information. So basically what we're going to be doing is interpreting this data from this graph. So first it's asking us to find the value of our function f when x is 0. So evaluating f at 0 and f at 6. So what we have to do is figure out what is the y value, because that's what this means, f of 0, when x is 0. So we go to where x is 0, we have this ordered pair here, and then the y value would be 0. So f of 0 is 0. And then similarly we do the same thing at 6. So go along the x-axis, come to where x is equal to 6. So we have this point here. And again, the y value is 0. So f of 6 is 0 as well. And then we also have these other 2 points that we're trying to find, f at 2 and f at negative 2. So if we go to 2 on the x-axis, we can see that we're not at 0 anymore, we're down here. We want to know, well, what is the y value here? It's negative 2. So f of 2 is equal to negative 2. And then at negative 2, when x is negative 2, we have this point here, and its value is 1, right? The y value is the value of our function. So f at negative 2 is equal to positive 1. So in this next part, it's asking us at f of 3, is our graph positive or negative? So when x is equal to 3, is the value of our function positive or negative? So if we go to 3, 2, 4, it's in between here at 3, we don't know the exact value of this point. And we actually don't really need to, because all we need to know is it positive or negative? And the way that we determine that is its location with respect to the x-axis. If it's below the x-axis, that means it has a negative y value. If it's above the x-axis, that means it has a positive y value. So in this case, at 3, when f is at 3, we're below the x-axis, which means it's negative. The next one is looking at the same thing. It's asking the same question, but this time when x is 1. So at f of 1, when x is 1, what is the y value? So you can go down here. Again, we don't know this exact value, but we don't really need to. We just want to know, at f of 1, is it positive or negative? So again, it's below the x-axis, so that tells us it's negative. Okay. So next what we're looking at is, where is our graph, right? So it says, for what values of x is our graph equal to 0? Is it equal to 0? So this is just saying, where is the y value equal to 0? What values of x make our y value 0? So we can just kind of go along the x-axis, right? Because that's where which has a y value of 0. Just walk along the x-axis and figure out, when does it hit our graph? So we have a point here, again here, and again here. So in 3 places it hits our graph when y is 0. And those values of x at which that happen are 0, 4, and 6. So x equals 0, 4, and 6. And then lastly, we want to know, where is the graph less than or equal to 0? For what values of x is our graph less than or equal to 0? Well, what does this mean? It's asking us, where is our graph negative? And we know that our graph is negative when the values are below the x-axis. So we have to look at our entire graph, and then we're going to figure out what interval is that true over. So we see that our graph starts here at negative 4 and then stops over here at an x value of 6. And then in between, it's both above and below the x-axis and also on the x-axis. So we're looking for the interval or intervals in which our graph is below the x-axis. So we can see that here it's above, here it hits the x-axis and goes below the x-axis, Here it hits the x-axis again and goes above, and then comes down and hits again. So the only place where it's below is in between here from 0 to 4. Now, because this is strictly less than, we are not going to be including these endpoints, because at these endpoints, our value of our function is 0. So if you remember when we talked about interval notation, if we are not including points in our interval, we use parentheses like this. Now, if you look at this, all the values in between those two endpoints, for every x value, if I pick any x value in this red area, you can see that it will correspond to some negative y value along that entire interval. So every single point on that interval is going to be less than 0. So our interval notation is going to be from 0 to 4, not including either of them. So from 0 to 4. And we could have written this in set notation. In set notation, it would be, it would be the set of all x such that 0 is less than x is less than 4. Now again, we're using strictly less than here because we're not allowed to equal the endpoints. At 0 and at 4, we know that our graph is equal to 0, and we want it to be just less than 0.